Very interesting topic we are going to discuss today. Tree diagram, which you might have heard this very often, but let me stretch a line and then say that tree diagram can also helpful in solving complex mathematical problems, right? So we're going to take a look on this scenario. The scenario is like a probability test. There are two events. Event one is disease. Event two is the test for disease. And then you have a result as a marker. Let's go through the scenario. Person does not have disease. We call it as healthy. Person has a disease. We call it as sick. Very simple. So now you have a given data 9,999 in 10,000 been marked as healthy. And then one has a disease, 1 in 10,000. Okay. This scenario has been put into test. So you see that only one person, let me give the number, 99 divided, the double nine divided by 10,000. So you can see here 99.99. Okay. But when it goes to a test, right, it is slightly different. And again, the same way you can do it for this also as well. 1 in 10,000. And the remaining number you have for sick, right? But when it comes to test, right, valid test 98 of 100 been marked as healthy. That means 98% of the time, and the test report says that it is healthy and all. But invalid test, right? So 2 of 100 been shown as, although they are healthy, but due to the reporting, it shows sick. That means 2%. Right? So, and then you have another scenario. Person has a disease, okay? And 99 of 100, it shows sick, that's correct. And then invalid test, and 1 in 1,000, 1 in 100, it shows healthy, but actually the person has a disease. How many healthy people will get, how many healthy people will get a sick result? That's what we are going to test in this. We are going to keep it like 1 million number, that 10 lakhs, you can call it 1 million, and then we are going to test this one. Okay. So the same thing, same scenario, you can explain in tree diagram. So what is the event number one? Event number one is healthy and sick. So we can call it as X and Y. Okay, two event is there, right? Healthy and sick. From there, you have a test, right? So valid test, invalid test, valid test, invalid test. You can give minus, plus, plus, minus, and so on, right? Valid test, test is valid and the person is healthy, it's good. And there is a scenario that healthy but invalid test is there, right? And so on and so forth. And then similarly, sick, valid test, and sick, invalid test. So we can call it as A, B, C, D. That means four scenarios you have. Okay. And then now the question is that how many people we are going to test? We are going to test 1 million people. Okay. And then we're going to find out that healthy, how many people are there, and told they are healthy. I mean, how many people are there, and in terms of percentage, in terms of number, and then sick, how many they told is sick, and what the report, incorrect report is there, right? So that's what we are going to do. So, I'm going to take this number, right? So take this one, X and Y, and so healthy, as you know, that 98%. Why 98%? You can see here, 98 I have taken from here. Okay, I'll keep it here. And then the remaining 2% is sick. The same thing is being put here. Okay? First, we can convert that into percentage so that we can easily calculate the total number of people. And then the second one is that 99 is a sick, right? So then you have that 99, and then the remaining 1% is sick. Okay, so this is what, but they told it is healthy, right? So the remaining one due to incorrect one, due to here the margin of error is 2, here the margin of error is 1. Okay, let's assume that you have been tested with that number. So how many number of people been tested? Let's say I can make it like 1 million. 1 is 6. Okay, I just put this in the the scientific number. If you wanted to convert back to a number, you can do that also as well. Okay. Okay. So now this is percentage been found, and now the ask is that 1 million people have to be tested. Okay. So very simple. All you need to do is that let me delete everything. Just multiply this times this. So this is going to be dynamic. So I'm going to give a 4. That means this is a number. For example, let's say you have that. So 980,000 people will be told healthy and they're healthy. Test report also says the same thing. Here we are talking about only 2%, right? The remaining 2%, but that 2%, if you put it, it goes to a big number. You can see here. So it is so 20,000 people, right? And similarly, you can just put that number, right? Whatever the sick people are there, you can test it, and you will get the number also as well, right? So here 99. So I will put that the sick people. So how many are there as sick? So 1%, right? 1% of this one, right? Okay, 1% of this 199, 1% of 1 million. Okay, 1% of 1 million. Okay, and you can see here. So it's easily they were being told as sick and all that. So this is the number. And the same thing, if you put this here and the 1%, that means they are actually sick, but the report says they are healthy. That is 101. So we can easily calculate using this very technique, right? And if you have further questions, you can just let me know in the comment section. I hope you find this one useful. Thank you so much.